Hi guys, and I hope you're good, and I really hope that you're enjoying your lecture so far. We coming here to the last lectures, like the last lecture of chapter number 3, which will be speaking about basically security, protocol layers, service models, and the history of the internet. A very short one. So, okay, we'll start by the security. The security is a very important topic in networking because we have a lot of issues with internet. Internet is a great network that uh, uh, collects, that basically brings the whole world into that little space where we can exchange ideas and stuff like that. But like in the real world, where we have thieves, where people break into houses, we also have hackers that can also break into your privacy, which is your computer, your network, and anything that is related to your network, right? So here we have some little problems that we encounter when we using the internet, which are, like I said, the hackers, and then they can get into your system using multiple methods. The most well known in here are the viruses. So viruses are computer programs that are basically created by some people, right? So they are basically created by some people to harm some other ones. And what they do, they can send a virus that can replicate itself into that can execute itself into your computer to do something malicious, deleting your file, rebooting your laptop, or stopping you from doing something, or overwhelming the RAM, something like that. And then it can get into your computers using an email, a website, a USB drive, whatever. And then you have a worm. A worm is a type of malicious software that can travel between computers of the same network, right? And that's very bad. They will just infect multiple computers of the same network the same way, and then can bring that down. And that can be a big disaster for your company, right? And we have those spyware malwares that can keep the keystrokes of your computers. We call them key loggers. Those we basically call them key loggers. What they do, they basically report everything you type to the hacker that basically sends the virus or the Trojan horse into your computer. A Trojan horse is a type of virus that is like a normal file. It can be an empty MP3, it can be a zip file. When you open it, it just starts spraying all the viruses it contains into your computer. And then the botnet. A bot is a little computer, right? And then a net is a network. So a botnet is just basically a set of little stuff, or a set of computers that will attack, that will be responsible of what we call a denial of service, or a distributed denial of service. They basically attack a victim computer or network in a distributed fashion. So let's assume that in a denial of service, you have multiple computers that are all together. They don't even know that they work together. But then a hacker will take control of all those computers. So they will use those computers as proxy to hack something. Let's assume that the hacker was to hack a bank. And the bank here is what we call the target. So when the hacker identifies the target, what it does, it basically sets the target there, and it takes all the zombies computers, like the hackers here, and has the control of all these computers, right? And then he or she sends an instruction to all that swarm set of computers to say, okay, destroy the security system of that particular server, and then the hacker will now get access to everything he or she wants from the server, for malicious purposes. Packet sniffing. Packet sniffing, it's a way of reading the information that are traveling through the networks. It's like user B wants to access some things in computer. Uh, User B wants to have access of stuff in computer A, right? But then the hacker is here. The hacker is basically sitting right here using a software called Wireshark to read your information. And when it reads your information, it basically tells everything, especially if you use public Wi-Fi's like the ones in the airports or stuff like that. So it can have your username and your password in the packet, and then the hacker will be able to get hold of that information coming from you and use it whenever. And it can be your email address, it can be your bank details, it can be anything. And that's also very malicious. You okay, this is it. So in your payload, the 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 hacker will be have access to it and then make use of it, right? Now you have what we call IP spoofing. IP spoofing, let's say you want to access a server A, right? Maybe you want to access the VITs, a staff member wants to access the VIT staff area. But then you as a student, you want to see what the VIT staff looks like, right? But then what you do is like you'll be sitting on a network and then you will be listening. And then you listen that this guy is trying to access the VIT staff. But then in like and then you let the connection go. No worries. But then what happens is that you kept track of the server, you kept track of the IP, and you kept track of the information that was requested to get authenticated and even authorized into that website. So what you do, or what the hacker does, is like it takes the information and request as well on computer A, because it's not authenticated on computer A. Then computer C puts a mask on and say, okay, cool, listen, I'm computer B, and then these are the credentials, please let me in. And computer C will be let in here in server A, and server A will think that it's actually computer B that's making the request. And the consequences are very, very, very bad for computer B, because when we do the audit will happen on computer B for computer B, right? So we will be speaking about security and see how we can come across this type of issues. Now let's go to the protocol layers and the service models that we can encounter when we're doing networking. Okay, so let's go with that. A computer network is made out of multiple pieces, as we saw in chapter 1 and chapter 2. Then we have multiple elements, which are the host, the servers, the media, the applications, and all of those things that make up a network. But then how did they come all together, right, to solve that particular problem, right? So let's take the analogy of an airline, or when you want to travel. When you want to travel, you know that you have some steps to follow. You need to reserve a ticket, like you need to choose a destination, reserve a ticket, and after reserving the ticket, you go to the airport, and then you book you basically board a plane, right? These are the different steps that you take. And then the aircraft will be flying, and it'll be flying to the destination. And in the destination, when you land there safely, then you go through the same process, right? The aircraft goes to the tarmac and then lands on the ground, and then you go and get your luggages, right? You can see that this whole process is a structured process of traveling, and different uh, set of elements here are called layers. A layer is basically a set of rules that regulates a process in here. Like it does something atomic, it does one thing and one thing only. So if you go to the ticket, you will do the ticketing only. If you go to the ticket, you will do the ticketing only. If you go to the boarding an aircraft, you have to make sure that you checked your luggages in, right? If you have them. Even if you don't have them, you will go to the same queues as everybody, but then you will go faster because you do not have any luggages. The plane cannot fly without you if you didn't if it didn't go through the takeoff procedure. And when you go to the receiving end, then the aircraft needs to land, and then the whole procedure also goes its way. All right, so as you can see, this is the whole procedure on how it works. Now, in the layering into the complex systems, it's a bit different, or let's say it's rather similar to the object-oriented process that you know, right? Remember, in your object-oriented class, you have what we call a class, and then a class has a main function, and the main function basically receives all the other functions, right? All the other functions that are required to solve a problem. Let's assume that we want to calculate a compound interest. And to calculate the compound interest, you need to do some additions. That's one layer. Multiplication, that's another one. And then division, and then the compound interest. So as you know from object-oriented programming classes, the structures allows identification. Each function should be identified by its name and its relationship with the bigger system, right? Each and every function is being called a module and should be easy to maintain, easy to update in accordance to how the bigger system works, right? And then there are some few questions. Are layering harmful? Hey, like it's a personal question. You are free to answer it the way you want. But layering or breaking stuff into little pieces, it's important. It's very important. But then you can have repetition into the whole system, right? Um, let's say a system that was dealing with timestamp can have timestamp repeated somewhere down the line, and these type of errors. And layering in other complex system. Let's take, for example, in a car, right? In a car has a layering system that is very, very hidden to you. When you get into the car, you turn the key on the ignition, the car starts. But when the car starts, multiple things needs to go together. You have you have the steering wheel, you have the alternator, you have the engine, you have the radiator, you have multiple little components that do one single thing so that your car can drive to your destination. Very important, the layering. All right. Now the internet that we all use a stack that we call the internet stack, right? And the internet stack, it's basically a set of it's the internet stack is a set of rules that we all use for message delivery, right? So the internet stack is made out of 5 well separated layers: the application layer, the transport layer, network layer, link layer, and then the physical layer. All of them do a single thing at a time. So we will go through each and every of those layers one by one very quickly, starting by the application layer. So the application layer, that one is what we all know. And for that instance, those are, we'll take the browser, the different browsers that you know, the big ones. Okay, here they forgot about Brave and the New Age and, like, you know, all of those hectic browsers. So the browser, it's your entry point to your network, to the internet. And there are multiple other things. You can browse. You have your Spotify where you can get your music on. You have your your Gmail, your Apple Mail, or your Outlook. Those are the entry point, and those all use application layer protocols. HTTP for your browser, SMTP for your messages, FTP for your file transfer when you want to download an MP3 from the internet legally, then you use a file transfer protocol. You can use what we call Telnet, that's a remote terminal. There are so many protocols, so many of them, right, that you can use, and they all come with their IP. They all come with their port number, right? The next step is the transport layer. The transport layer has some protocols that we all heard about, the TCP and the UDP protocol, right? Uh, the TCP, which is the Transmission Control Protocol, it's the most reliable protocol from the two, but then not the best, right? Because the UDP is not very reliable, but then it's also very important to use, right? So the TCP is what we call a connection-oriented service. It is rather slow because it needs to check a lot of things. It is slow for sure because it does the following things. It guarantees that the message arrives. We have to make sure that the message arrived in its integrity. It breaks big messages into smaller chunks, right? To make sure that it goes quicker and faster. Or it's like it's slow relatively, but then it breaks it into smaller pieces that will be then reconsolidated on the receiver's side. It does what we call a checksum. A checksum is a way of verifying that the data is in integrity, right? The data is integral. It's like if we send 10 liters of water from one side to the other, we need to make sure that 10 liters arrive, right? And then the TCP are mostly used in browsing. When you want to get to a web page, then it uses the TCP to make sure that we receive the whole page in order. Email addresses, WhatsApp messages, file transfers, specifically file transfers. When you do a file transfer, all the packets are not arriving at the same time and in the same order that they left the host computer, right? They come in different order. It's like we have a file, an MP3 file, 1, 2, 3, 4. When it goes over the network, it can go 4. 4 can be downloaded first, then 2 downloaded after, then 3, then 1. Then the whole thing will be consolidated. 1 after 1 comes after, after, okay, let's do that. Then, so we were here. So we are having after 1, we have 2. After 2, we have 3. And after 3, we have 4. And then they all merge together. And then you have your MP3 file. That's how it works. Now the UDP, it's a connectionless type of service. It doesn't respect anything that the TCP does, but it doesn't mean that it's useless. It's very, very useful. Like if you want to make a phone call, for instance, right? You don't need, like if I'm counting from 1 to 10 and then I skipped 5 to 6 and then I say 7, you don't need to care about what I said before. You know that I went to 5, 6, and then you know that I'm carrying on to 10. So it's mostly used in voice over IP or phone calls like Skype calls, Zoom call, even WhatsApp calls, and then you have your games, right? Where you can play your FIFA 10, sorry, your FIFA 20 or however you call it, and then something can stop, but then the game will not go and rewind what happens. It will just carry on, right? The packets order doesn't care. The packets just needs to arrive in a streaming process. YouTube. Yes, so that's how it works. The networking layer basically tells the computer or tells the network the whole process of the sending algorithm. So this is me. I'm the first IP. I want to send information to IP number 2, right? And then I'll be using a routing algorithm. There are multiple routing algorithms that can be used, right? And it will be selected on the network layer. And you have to keep in mind that the application layer will give a small header to the file. It's like, I mean, the application layer has the message. Now, after the application layer, we basically have the transport layer. The transport layer will say that, okay, this thing is using the TCP or the UDP, and that's basically what the transport layer will tell the message. And then there will be a network layer. The network layer will tell the whole carrier that, okay, cool, this is the IP that we're requesting the information from. And the link layer receive information from the network layer and say, okay, cool, I know where you want to go, but then we're using what we call the network interface cards, right? You see, it's getting now very physical. We left the whole part of the software now to get to a hardware, and the hardware is the network interface card, or as known as the network card. This network card has what we call a network port, and what you're looking at is basically what we call the RJ45, or called the Ethernet cable. This is also parallel to the wireless, the wireless network card. Although the wireless today are being embedded into systems, but then in the past it used to be like this. And each and every network card has what we call a media access control, or known as the MAC address. The MAC address is the ID of a specific network card. The MAC address is the ID of an NIC, right? But then the IP address is the ID of a particular application or a particular computer on the network. You need to make sure that you know both of them. Very, very, very important. Might appear in the quiz, so be careful. So after the link tells the whole message stack, it's like the message has been created in the application layer. We've been told what to be using, whether it's TCP or UDP. We've been told the routing or the routing algorithm that it will be using. And then it's like we have the MAC address information given to the network procedure. Then we have the physical that I will not speak about, the physical layer here that says, okay, given the whole information down to the link level, I will make it cross to the whole network and send it to the receiver. But then what the internet stack doesn't have is the presentation layer and the session layer, and they all belong to what we call the Open System Interconnection, the OSI, right? The OSI has two more layers, the presentation layer and the session layer. Most of you might be aware of what we call the session layer. The session layer is that part of a website that basically tells you who logged in, who got authorized, how long time you're spending in a particular session open. You might have heard about cookies that basically store a couple of informations about you. Facebook knows well about that. That's how they know who you are, what type of advertisement we need to give you, right? The session layer is there for that. The presentation layer is basically another layer that will help the session layer to better work. Take the username and the password, send it there, and tell me whether that particular user has been authenticated. Take any file for authentication as well, or multiple other things. That's the presentation layer for the whole layers coming down the line, right? Remember that the internet is missing those two layers, the presentation layer and the session layer. But then most of the time, we take the application, presentation, and session layer as application layer. Those are not very important. It depends on what the programmer wants to do. Let's assume that you wanted to read an information about a post, South African post. It's just about reading, reading a post. You don't need a presentation. I mean, it's like, yeah, you might need a slightly one, but then you don't need actually those two layers for you to read a blog post, all right? If that blog post doesn't need any authentication or whatsoever, then the internet thing does it, right? But then if you need some sort of authentication or complex stuff to get to your transport layer, then the OSI might come into the picture. But then do not take it as OSI, take it as internet as well, but then with extra features, right? So it depends really on what we need to do. Now, this illustration will show you an, basically an explanation of what we call encapsulation. The message that we need to send needs to arrive to the destination, to the application having the destination. Let's see, when we send a message using WhatsApp from one friend to another friend, from one group to another group, we just read the message, right? But then the message is going through a lot. And through that lot, we'll be seeing that right now. So remember, there's a way of doing things. When you want to send a letter to the post office, then you need to put your name, you need to put the destination address, and then the post office will put some other things so that it's well routed to the destination. Or when you order something on the internet, same thing here. So the message goes to the transport layer. The transport layer will tell, okay, you know what, take this little bit, this bit, and turn it into a segment. And remember, you're using a TCP protocol. So the message knows that, I mean, the network will know that this guy will use the TCP protocol. Now it's going to the network. It's going to the network part. Right, the network part says, okay, this guy is trying to use the TCP protocol, so we expect the feedback. But then now, this is the IP of the particular application, right, and the port and whatsoever about the network. And this is the routing algorithm that we'll be using to send the message through the TCP protocol. So it adds a new layer to the message, or a new little piece of information, and then the whole thing will be called a datagram, right? A datagram, remember, we are having a segment at the transfer layer, we are having a datagram at the network layer, and the datagram has the transport piece and the network piece. Now we go to the link layer. The link layer will basically authenticate or basically identify the medium or the network interface card that's making the request. There are multiple other things that happen in the link one, but take it as is now, right? It will add its little bit and then you'll turn it into a frame, right? The frame will be then the set of data that will be sent across. Now the physical layer doesn't have any little thing added to the message. You see, it will just cross through the network, and then you'll even cross the links, the switch. Something say, why will it cross the link, the switch? Yeah, you'll cross the switch because the switch doesn't have anything to basically add to the message or to basically the frame. It doesn't have anything to add to the frame at all. It just says, okay, I read where you came from, and I know where you're going to, but then I'll send you somewhere where you'll be again relayed, and then it relays that, guys, to a router, right? A router is more clever than a switch because it has some thinking. So what this thing will do, it will go to the physical. It's like, okay, I'll receive this guy, right? And after that, it will remove the link layer. Okay, I know where you're coming from, or the MAC address where you're coming from, not very important. And then I know basically the routing that you want to use. Remember, when it was coming from the source, right? the network told him that, okay, I want to go to Facebook. Sorry, I'm mentioning Facebook now, but then, yes, now we're going to Facebook. And this guy would say, okay, the message is intended to go to Facebook. So what it will do, it will go down the line and then redefine a new link and a new network, right? And we'll go to the physical layer, we'll slide to the destination. This thing arrived. The aircraft landed. Now it needs to take the link out. Okay, so where are you coming from? I'm coming from that particular router, and I had been initially sent by the source computer. Granted. Now, sent by the source computer, the routing has been done. Is the destination the destination? Yes. Network granted. Now the transport layer, TCP/IP protocol or UDP, whatever. Okay, I'm using TCP. So okay, remember that you need to send a feedback. Granted. And then the message get read by the application. In other words, it's us reading our message coming from the guy or the lady, respectively. Yes, so this is basically the encapsulation process. The encapsulation process is that process of basically making the message travel from the source to the destination, transforming from a segment, right, a datagram, a frame, and making it cross the whole network, going back and then it does a de-encapsulation so that we get the message. Right? This is encapsulation for you. Now we go to the very last part of the lecture, which is the history of internet. I won't spend too much time on that. I posted a link of a particular website for you on Moodle so that you go and read that. And but we'll go through some few stuff. You have to know that the internet was just a little network that was made for military use. So, you know, in the military, they have multiple very, very, very protected networks that they use so that the enemy doesn't know what they speak about, right? And after that, it's been expanded to civilians, like when they built the Hummer. The Hummer was a military car that has been turned to a civilian asset that we can all use. You can now buy a Hummer. Like the internet, you can use the internet to whatever. Today, remember, we use internet for literally everything. But then as we go through time, we are just having some few numbers of nodes on the internet, right? And as we started growing, we started implementing the TCP/IP protocol and the SMTP for emails and all of those stuff. When you send your email, it goes through, someone can read it and respond to you, and then you have your FTP that came some few years down the line, and then you have your congestion control that makes sure that, remember that the TCP, other than creating the checksum and all of those stuff, it can, there's another nice feature about the TCP that can regulate the flow of information, right? So if the server is sending at 10 megabits per second a message, and then the destination receives stuff at 5 megabits per second, since it's a TCP, it's a two-way communication. The phone or the phone or the computer will say, okay, listen up the server. I can only receive stuff at 5 megabits per second. Can you please slow down to 5 megabits per second so that I can receive your message, and then there's no overflow. That's what the TCP was there for as well. And after that, we started seeing the web. Like you see that network of networks, the World Wide Web, www, where we have a name for a website and all those stuff, HTTP and all these type of things. And as we grew into our networks, we started having Facebook, which has a very big amount of interconnected network, and then they ended up creating what we call a social network. And then we also have multiple connected devices that brought into the picture what we call IoT, or Internet of Things. So there are multiple things that can now connect to the internet: fridges, smartphones, smartwatches, smart everything, smart cars, smart house, everything that has the word smart on it. Yeah. So that's basically the end of our chapter one. And as a summary, remember we went through an overview of what the internet is, what all of these little components are. We spoke about the protocol, which is a way that people are speaking to each other or systems speak to each other. We saw in this section what is a packet switch network, what is a secret switch network. We saw the packet switch network basically sends packet across the network and then goes and get basically reassembled on the destination, where we are having the secret switch network that relies on a circuit. It makes a connection, a strong dedicated connection between the sender and the receiver. We're having two type of secret switch network, which is the TDM, the time division multiplexing, and the FDM, the frequency division multiplexing, where we are having the bandwidth allocation to multiple users, given that that one is very inefficient, because if we have bandwidth for 5 users and then there are 4 on the bandwidth, there will be one fragment of the frequency that will not be used, and then the one time slot that will not be used. So yeah, and after that we talked about the throughput, the delay, and the losses of data across the network. We spoke about basically um, different sort of delays: nodal delay, queuing delay, processing delays, and transmission delays. And we spoke about the loss of data in the network, right? We also spoke about the throughput, where we are speaking about the different speed and the transmission rate that a message can go from a client to the server through a router, and the throughput of the whole connection being the file size divided by the minimum throughput rate, right? By the minimum rate between the two channels, or the two links. And in this lecture, we spoke about security, layering, and the history of the internet, right? But then, as an added value, we have Wireshark. That's a free network that will help you to sniff into the network, know exactly what's going on. Just be careful with what you do, because you can actually get the username, password, and all sensitive information that can travel across your network. And remember, you if you can use it, you can do that for very nice use, like you want to debug a network, you want to do network administration, you want to do all those things. But then you will be liable for any wrongs you will be doing with this network if you happen to steal some information or misuse some information that you got from Wireshark. They have a they have some terms and conditions that they want you to agree to, so that they will be far from you if you do something wrong with it. So this is the end of lecture one, and I hope that you really enjoyed it. And I will be creating some nice practicals for you, very exciting ones that will require you to write some hectic codes using C++, Java, assembly, whatever you feel like, and then you'll be doing that in groups. Other than that, you will be enjoying your quiz, and have a good week. Bye.